Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Ruben Saltzman. I'm your host, alongside building science geek Tessa Murray. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back to the Structure Talk podcast. Tessa, as always, great to see you. It's been
good to see you too.
Weeks. We have gotten off of our routine of recording a podcast every single week, but man, we've got no shortage of topics right now. I think I've got about half a dozen things that I want to do podcasts on. So it's not because we're out of ideas. Tessa and I just have not been able to get our calendars to line up to record these.
Life happens.
Life happens. We get busy. You know, it's tough to find an hour where we're both free at the same time.
Well, I'm super excited about this podcast, Ruben. Why don't you say who we have on today?
All right,
we have a special guest.
Well, you guys already know each other. We got Tom Harris, and Tom Harris is an expert when it comes to spray foam. And we're having him on because we had someone come out and speak at our local ASHE chapter, the ASHE Heartland chapter. And they were coming out to do some education on SIPs, structural insulated panels. And the conversation really moved into a lot of defects with spray foam. And there were so many things that I just wasn't even aware of. This is like a new world for me, all the stuff that can go wrong. I knew there could be problems, but I thought what I don't know about spray foam could fill a warehouse. And so I was asking Tess, who do you know who could talk about this? And immediately you said, oh, Tom Harris. He's our guy. So how do you know Tom? How do you guys know each other?
Yeah. Okay. Well, I'll start real quick. I actually, I ran into a coworker of mine randomly. I have not seen him in years. I used to work with him at Cocoon, and he was a spray foam installer. His name was Bill Bilbin, and I lost touch with him over the last probably 5 to 10 years. And when I ran into him, we started chatting. Turns out he has created this national organization to help educate spray foam installers, contractors. They've got a Facebook page. It's called Spray Foam Worldwide. I think they've got over 16,000 members. And learned that he's kind of a big deal now. And he holds these national conferences annually to help kind of just improve and elevate the spray foam industry. And he said, you know what, Tess, you should really meet Tom Harris. He's an expert in the industry, and I think you guys should get to know each other. So that is, in a nutshell, how I met Tom. And so then I met Tom for coffee one day, and I don't know how many hours we chatted, but Tom, I am so excited to have you on the show. You have so much knowledge and experience with spray foam. I can't think of anyone better to have on. So thank you for saying yes.
Yeah, great. Thanks very much. And it's good to see you again, Tessa.
Good to see you too.
People who know me in the industry and your reference to speaking for hours, they're probably going to giggle because I have a tendency to do that a lot. Given an hour, I'll take 90 minutes for sure.
Well, you've got some fascinating stories, and we want to dive in today. I mean, we'll definitely touch on the technical things. I know Ruben has a bunch of really good questions about spray foam and, you know, and how it can go wrong, how to identify improper installs, proper installs, all of that. But before we get into that stuff, do you want to tell us a little bit about who you are, what your business is, and kind of just in a nutshell, all the experience that you've had over the years that have led you to where you are today?
Yeah, sure. I can do that in 90 minutes. Started in the industry, actually, upon graduation out of Toronto, Ryerson University. It's now called Metropolitan University. But 1981, graduated with 4 students, me and 3 other guys in polymer engineering technology up there. And polyurethanes, you know, we had to write a thesis and all this to graduate. And polyurethane is a chapter, maybe a paragraph, a page and a half in the books, you know. And I graduated. I talked about in my thesis the use of polyurethane foam in automotive, dashboards, steering wheels, all kinds of different uses for this soft, squishy material in the automotive industry. I thought, well, that's pretty cool. I'll write on that. So I graduated, and being only one of 4 graduates, we had a stack 3 inches high of companies in the area that wanted to hire the graduates. And my first one was into an adhesives company. I wasn't too interested in that. But my second one was this polyurethane stuff. And I thought, well, I wrote about this. Maybe I should take a look at this opportunity. So I went into the interview, and they talked about, this is spray foam and this is polyurethane foam insulation, not like the automotive stuff, but more rigid. And they explained a little bit about it. And I thought, well, that sounds pretty cool. And they said, how hands-on are you? And I happened to mention that, my first car came in 4 pieces that I had to put together. So I get automotive and mechanics and that sort of thing. They said, well, good, because there's a lot of equipment that'll be used and you'll be exposed to. So that's kind of cool. So we went in the lab, took a bit of a tour, and they showed me, they mixed the A side and the B side together. And within 3 seconds, poof, it went from a liquid to a solid. And I thought, that's cool. That's neat. And they said, you can engineer this on the molecular level to make it do whatever you want or the customer wants it to do. I thought, really? So I can be like a wild lab guy, the lab coat and that sort of thing, and mixing
crazy
the
mad scientist.
Yeah, exactly. I thought that would be cool. So I took that job. And that was in 1981. And you know what? Sales meetings, corporate wise, you get into these sales meetings and they're always talking about their competition. And there was a particular competitor that was just down the street. And boy, if they ever got into spray foam, the world would be completely different. And I thought, well, if y'all are afraid of him, why am I here? So I was approached by that company that was down the street, happened to be BASF. And I introduced spray foam technology to BASF Canada in 1985, and actually worked with them in Canada, got a huge market share. Everything worked great. I was their chemist, their marketing person, their salesperson, set up distribution channels. It was a great life. And so kind of sitting back, we're enjoying our market share. And they said, work good in Canada. We're going to move you to the U.S. So that was in 1993 to introduce spray foam technology to BASF US. So I spent all in all about 23 years with BASF. And it was a great adventure in both Canada and the US, and different strategies for Canada versus the strategies to get into the market in the US. In the US, we acquired different companies. So that was a different approach. But you can't grow things quickly, organically, here in the U.S. You've got to make acquisitions, and that's still reflected today. You see all kinds of companies making different acquisitions of different companies within our little spray foam industry, and we can talk more on that later. But I wrote the manual on how to get into the business for BASF, and I think on page 640 it says move the business to Houston, Texas, the site of one of our acquisitions. I'm Canadian, so I'm not going to Houston. I spent a year down there, and I started to sweat in March and didn't finish until November. So that climate's not for me. So we parted ways after 23 years. And there was a company called Honeywell. They manufacture one of the raw materials, the blowing agents, the key component for resins and polyurethanes. And they were excited to know that I was on the market and available. So I spent 10 years working on this new molecule, HFO, the low global warming potential molecule that the EPA requires us as insulators to switch to. So I helped them develop and market globally that particular product. And, it spent 10 years there, and it was winding down my contributions, and a company called Demolac back in the systems house side. They're manufacturers of resins. So they were interested in having me come on and rebuild their building science department selling and pulling through the demand for urethane foam. And I was managing the technical development side, the chemistry side, and the field tech service people. So it was quite a lively group, stretching from Montreal to Vancouver down through the U.S., and they were centered in Arlington, Texas. So I spent a lot of time between the Montreal plant and the Arlington, Texas plant. And, I'm getting up there in age at this point, 59, 60, 61 years old. And I thought, eventually I'm going to become a consultant. And the opportunity presented itself when Huntsman acquired Demilec. They rolled up Huntsman, Icynene, Lapola. Now they're a big player in the U.S. and global spray polyurethane foam under Huntsman Building Solutions. So that was great, and we integrated the companies, and everything's going along swimmingly. And we decided it was time for me to be a consultant. So I left Huntsman, became a consultant, and I've been doing that for the last 3.5 years now.
Okay.
And yeah, that's been really interesting. I mean, I get to talk to everybody from manufacturers to contractors, where Bill and I really hit it off, and he's got access to 15, 16,000 members on his Facebook page under Spray Foam Worldwide, and that's my target audience, is these contractors, helping them achieve better results, telling them and training them, teaching them what they don't know. And it's I'll tell you, it's complex. It's not easy. And we'll touch on a few of the issues coming up. But, it's interesting. You raised the point about the problems of foam, Ruben. And yeah, there are. It's not easy to manufacture something in the field. Most insulation products are manufactured in a plant under controlled conditions. Mm-hmm. And what we do in our industry is we bring the raw materials to the job site and we manufacture that product on site.
And,
so it's challenging.
I want to pause just for a second there before you continue. Just for anybody listening who doesn't fully understand how foam is used in houses today, what are we doing with this stuff? How is it used in a residence?
Yeah, it's insulation.
Okay.
Now, there's a number of attributes to any insulation product, and we're commonly referred to the R value of insulation products. And there's a ASTM, American Testing of Materials, kind of test method that goes along with that. And things like fiberglass, cellulose, rock wool, spray polyurethane foam, expanded polystyrene, that's that white bead board. Mm-hmm. The pink, blue board, the extruded polystyrenes. And you mentioned SIPs panels. They're insulated with polystyrenes. There's one manufacturer that uses polyurethane, but polyurethane is an insulation product in our context. I mean, it's used, you're probably sitting on polyurethane right now. It's carpet underlayment. It's those fancy mattresses that you lie down in all night. You're in complete contact with polyurethane foam. You put your head into a polyurethane pillow, when you sleep. It's all around us. So understanding polyurethane spray foam and insulation, it's not new. It's been around for quite some time. And, it's manufactured on site, which presents some problems. But in most cases, 99.9% of the time, it's manufactured correctly. But it's primarily the insulation material that we put in studs or spray to the underside of roof decks or on top of our attic floor to replace other less effective, less efficient insulation materials.
Got it. And for the listeners, the one place where we find this material on just about every new construction house, we found it probably in the same place for the last 20 years or so, would be at the rim joist. we used to use fiberglass insulation at the rim area on new construction, but today that's kind of a thing of the past. All we ever see is spray foam insulation. And that there's a lot of homes built today where that's the only place we find it, with the exception of, maybe around windows and doors, they'll kind of fill in some of those gaps. But that's minor. But we always see it around the rim. But the other places where we're starting to see it more and more often is throughout attic spaces and maybe even being used in walls. Am I missing any other common places where we're starting to see it more often, Tom?
Yeah, in Canada, for example, and it's taking hold here, but they use it below the poured concrete slab for a radon barrier.
Sure.
Now, because it's insulation, it's also now giving that concrete the ability to have these radiant barriers and whatnot, radiant heat systems for heated slabs. So it's providing insulation and radon barrier protection. So, I see that application coming to the U.S. as well. If you're sticking to the foundation, we see it in crawl spaces all the time. That's a popular use, is to become that crawl space becomes vented or unvented, but it's energy conservation, because spray foam is about R7 per inch, and that's closed cell. The other option of spray foam is open cell, and I'm sure we can talk about that a little later. But closed cell foam has an R value around 7. Fiberglass is, 3.5. Polystyrene, 3.5. Extruded polystyrene is about 7. Anything that uses a gas, and in a lot of the engineering vernacular, we call it a gas-filled cellular plastic. Okay, so gas-filled cellular plastic. Okay, let's look at polystyrene. Polystyrene, expanded polystyrene, takes a bead and expands it with CO2 or steam or whatever, but it primarily uses air as the non-conductive medium, like fiberglass uses air. Cellulose uses air. Open cell polyurethane uses air. And they all have the same R value, or close to it, plus or minus, half an R. But they're all around 3.5. Now, if you take those cells and you don't break them open, and you keep them closed, and put in that cell a very heat and thermal resistant material, then you've got a great R value. You've got a better insulation material. So that's what we do when we take open cell and we make a closed cell. We replace air with a different gas. That's that Honeywell HFO stuff that we talked about. We put that gas in there, and it takes the R value from about 3.5 to over 7. And some of the companies now in the industry are 7.9 per inch.
Wow.
And that's an aged R value. So that's pretty impressive. And that's why we see, with the expanding R value requirements in codes, I mean, if we use glass fiber, which still is by far the market leader for insulation materials, but if we use that, we'd have to be building on 2x14, 2x12. And that's starting to be a pretty thick wall. It gets expensive. So we start to understand why we're replacing common insulation materials like fiberglass and rock wool and cellulose with more effective, more efficient insulation materials like polyurethane foam.
Sure. Okay.
Yeah, so we get it. I mean, for the entire building envelope, the walls, the attic, the foundation, it can all be encapsulated with polyurethane foam.
And if someone's going to install this stuff, do you need a special license to do it? Or do you need special training? Do you need a certification? Who's qualified to install this stuff?
Yeah, there's an hour or two just on that topic. Yeah, Ruben, it's, you can buy a piece of equipment off of eBay or off of a distributor. You can buy the chemical from a distributor or even off of a website and get into the business. You'll need a contracting license. You'll need, in some states, an insulation contracting license. But the training doesn't specifically deal with the application, the installation of polyurethane foam. That falls back in our industry to a number of sources. And it's akin to a driver's license. If you want to drive a school bus, you need a special driver's license. If you want to drive a big rig, you need a special driver's license. And if you want to drive a spray polyurethane foam rig, you're going to need a special driver's license. Yeah, okay. Having said that, is there a special license for the application of spray foam? And the answer is no. But most of the contractors are members of the trade association, Spray Polyurethane Foam Alliance, sprayfoam.org, and there's training and certification for the installer, for the project manager, for the apprentice, all on there. You can take those training courses. You can go, you buy a piece of equipment. I would suggest, and it's always recommended, that you take the training, 3 to 5 days of training on that specific piece of equipment offered by the manufacturer of that equipment. So now you've got the equipment side trained up on how do we address the chemical side, because we're handling chemicals here. Well, the American Chemistry Council has a group called CPI, the Center for the Polyurethane Industry, and it offers safety training, worker protection, PPE, transportation of, spill cleanup. And that class is about 2 hours long. It's online and available, on demand. That's certainly a good place to start. Then the manufacturers of the chemicals themselves, in order to buy chemical from Company A, you need to be trained by Company A, because their formulation and their chemistry is different than Company B, is different than Company C. And they want these installers to actually have time with their training, with their tech service, with their chemistry before they pull the trigger on a job. So a homeowner can ask the question, are you a member of, are you certified by the Spray Polyurethane Foam Alliance, SPFA? Have you taken the manufacturers whose chemical are you going to install in my house? Have you been approved? And you can ask for that documentation. So there's let's call it the gross chemical handling side, safety side from American Chemistry Council. There's the specific chemistry that you're going to be handling from that manufacturer. And even the distributors now are offering training programs. So there's that side. There's the equipment side is covered. Now, any construction project, you're under OSHA. And it's always good to have OSHA 10, OSHA 30, this sort of thing. Safety awareness, fall protection, proper PPE. All of that information is available to the contractor, but there is no mandate to take it, to use it. And of course, basically, Ruben, we're a pretty litigious society, so if anything goes wrong, that's usually the first questions. Are you capable? Have you been trained? Are you certified to actually do this? Heaven forbid if the answer comes back, no, I'm not.
Sure. But do you think that most people doing it are trained then?
Most people. Now, let's not use flowery terms like most or some or all. I would say certainly more than 70% of the contractors have some form of education, either from the manufacturer of the equipment or the manufacturer of the chemical or the Spray Polyurethane Foam Alliance. I think our numbers are certainly above 50 and approaching 70.
Okay. All right. And now I'm just picturing a scenario. Let's say I'm the insulation dude. I've started my own company, went through training, bought a truck. I got training from the manufacturers on their products, and I'm starting to get busy. I'm doing jobs. Well, I want to help. I want help. So I know this. I know this 22-year-old dude. He's looking for work. He's handy. He's got a strong back. All right. I'll bring him in. I already know how to do most of this stuff. So I'll just teach him the basics. I'll teach him what he needs to know. Like, look, this is how you hold the gun. This is how you set the dials. And this is how you spray it. And I want you to do that bay and do these bays and grab me when you're done with that. How often does that happen?
A lot. That's pretty much the path to entry in the industry.
Okay.
There's no formal school classroom kind of training, per se at a local college level. It's all done at the distributor, the manufacturer, or the trade association,
or the employer.
But there's a lot of experience hand-downs. This is the way I've always done it. May or may not be actually effective.
Okay. All right. And I got this dude doing a lot of the work for me, but he starts getting sloppy. He's not doing things exactly the way he should. What kind of mistakes could he start making? And keep your answer to under a half hour, please.
Yeah, I'm sorry. I'm Tom Harrison. I will do that to you. What kind of mistakes can happen?
Yeah, high level. What would he do wrong, and why does it matter? And then what can be done about it?
Yeah, one of the points that you raised earlier in a conversation, Ruben, was the difference between open cell and closed cell. The client, the customer, may have wanted closed cell, likes the high R value. I'm going to put this much in it. And it tends to be a little more expensive. Wow. I'm just going to use the same thickness. I want 8 inches. That's R whatever, R24. How much for R24 closed cell? Well, that would be 3 inches, and it'll cost you this much. Well, the homeowner has confused the situation between a conversation around open cell and closed cell. So how does the homeowner know which one he's getting? And a really easy way to tell is by putting your finger in it. Once it's installed, closed cell foam, you can't push your finger through it. It's solid. Open cell foam, and I'm dating myself here, but if you've ever seen packaging foam, when you bought a high-end piece of electronics, it came in a box. In that box was silver plastic wrapped cushioning foam.
Mm-hmm.
That cushioning foam is open cell foam. So you can take your finger and you can push your finger through it.
Sure.
It's fluffy. It's quite light. It's what they call half a pound or 0.5 pound per cubic foot, which it's hard to relate to, but can I push my finger through it or not? And if you can push your finger through it, that's open cell foam. If it's hard, rigid, pretty solid, that's closed cell foam. So understand that closed cell foam has an R value of 7 plus. Open cell foam, the things you can put your finger through, has an insulation value of 3.5. So you may not be getting the insulation protection that you paid for or expected. That's problem number one. The next problem is that can be encountered is because we're manufacturing things on site, our environment plays a big role. Foam will not stick to things that has a surface moisture of greater than 19%. So frost or dust or dirt or anything like that. Foam works when it's stuck to things. It's not like a fiberglass bat that you stick into a cavity. We actually spray it out as a liquid. We wet the surfaces, and then it grows to become rigid, closed-cell foam in 3 to 5 seconds. Well, if that surface has got any contamination on it, it won't stick. And if it doesn't stick, some of the obvious failure modes to it not sticking is a gap between the foam and the stud, the framing member itself. And if you have those, it has to be replaced. You can't, we're not here to spray foam and then let it shrink and, it have gaps in it. Our claim to fame is that we're continuous, monolithic, all these great terms, but it's got to be stuck. It's got to be continuous. And our surface preparation plays a big role in that. And the other big mistake.
Sorry to interrupt you real quick. I can't tell you how many times I've seen a gap between the spray foam and a stud somewhere.
Yeah.
So you're saying that should never happen?
Never. That's not what we sell.
And
that's what the bats and the other stuff sell. That's not what spray foam sells.
Mm-hmm.
So I want to hear about the prep, but also I just want to put this number into context where you said 19% moisture. That is it needs to be below 19. 19 is a very high number. When we do moisture testing on houses, we're looking to find numbers 15% or less. When we find moisture content in a stud or sheathing and it's between 16 and 19, we say that's marginal. You could have a problem. If it's above 19, that's where you could have mold growth and the wood can start to rot. So you're not asking for a crazy low number.
Dry.
You're just asking for a normal amount of moisture. In fact, you tolerate a fairly high level of moisture. So
actually, Ruben, we're just asking them to measure it. Let's start there.
Yeah. So I just wanted to put that number into context for anybody who doesn't understand what these percentages should be. But and then where you left off was preparation. What does that look like?
Yeah, it needs to be clean and dry, contaminant free, less than 19%. All right. So now we've done our measurements, we've taken our notes, we know where the moisture content of the substrate is. Let's look at the environment itself. And there's two things in the environment we want to focus on: the temperature and the temperature of the environment itself inside the attic. Let's say we're doing an attic, and the substrate temperature, because they can be different.
Yeah.
And we want to look at the environmental relative humidity. So we're asking contractors to buy a surface moisture content meter, a thermometer, or a device that measures temperature and relative humidity of the air that you're standing in. Not a lot so far. You haven't expended a lot, but you've got a lot of information there. We don't spray foam in the open environment when the relative humidity of the air is greater than 85% or the dew point is within 5 degrees. Okay, so you can get frost on the inside of a roof attic, in the roof sheathing. You can see it. It's frost. Okay, don't spray it.
Yeah.
But it may seem dry. If you don't have a moisture meter and you guess, you may lose adhesion. If you actually took a moisture meter to the substrate and measured the moisture content, especially in the shoulder seasons where there's a big delta T from daytime to nighttime, you may get condensation that you don't see, that you can't feel, but it's on the surface of the wood. That's why that moisture meter is so important. It feels dry, it looks dry, but it won't stick. And that's, I think, where contractors are running into problems. And I think, Tessa, that's where you're seeing a lot of your situations that you've described, is that contractor touched it, it feels dry. We haven't had rain in a week. but it's not sticking. Why? Well, it's because of this unknown. If you're not measuring it, you don't know. So that's what the training is all about. We train you to take these measurements, to make these measurements, and to be aware of the effects. Surface prep is the number one thing I see. And of course, choosing between open cell and closed cell, the applicators need to understand that open cell is different than closed cell from a vapor, from a moisture management standpoint. It's a bit of building science, but from a moisture management standpoint, closed cell foam can tolerate a lot of moisture vapor. Now, when we talk about moisture vapor, we're talking about moisture in the air going through materials. That's vapor. So we're vapor impermeable, vapor permeable. We get confused in our industry, and it's no fault of the contractors. It's just an awareness thing and a training thing. There's a difference between being a vapor impermeable material and an air impermeable material. One talks about vapor protection requirements, and the code says north or higher than climate zone 4A. So in 4A, 4 marine, 5, 6, 7, and 8. And we're in Minneapolis, so we're cold. We're 6, 7. And if you use open cell foam, that's vapor permeable. So you need to protect that from vapor diffusion from the inside environment to the cold outdoor environment. And a lot of contractors miss that. They think that everything's a vapor barrier. Well, no, potentially an air barrier. Okay, I'll give you that. But air is not vapor. We're talking about code compliance to vapor protection, vapor barriers. And one of the big mistakes I see is the confusion between open cell requiring an additional vapor protection and closed cell, which does not. Okay? In Canada, for example, most of the homes are done with closed cell foam, and we don't add 6 mil poly or anything like that. There's nothing sprayed on the surface to protect it, and that's a cold environment. When we use open cell in cold environments, we have to protect them. Either a spray applied vapor barrier or a 6 mil poly, tape the seams, all the good stuff to get that vapor protection. And I think that's one of the big problems that we see.
Okay. And can you talk to me about what makes the difference between open cell and closed cell? I mean,
sure.
I understand the makeup. One's much lighter. One's vapor permeable at a depth of, I don't think you said this, but a depth of 2 inches is where closed cell becomes vapor impermeable, correct?
Yeah, it's about 1.5. Some companies, and it's formulation specific, huh?
Okay.
So, there's 16 plants making resin, and there's 54 brands available in the U.S.
Okay.
There's a lot, and you have to look at the technical data sheets associated with each particular material to know how thick you need to spray this closed cell material in order to become a type 2 perm rating of 1,
okay.
a type 2 vapor barrier. Some it's 1 inch, some it's 1.5 inches.
Okay.
But the difference between open cell and closed cell from a vapor protection standpoint, a vapor barrier, a qualifying as a type 2 vapor barrier, they'll never get there.
Sure.
Closed cell gets there in 1.5 inches. So if you look at it that way, and it all comes down to chemistry. You take those 2 materials, you combine the 2 in the gun at 120 degrees, just to pick a number. They boil, essentially, the blowing agent in closed cell foam, and that blowing agent boiling gets trapped in the cells. Okay? In open cell foam, when those 2 chemicals come together, the blowing agent is actually water, and you produce CO2, carbon dioxide. and it forms the bubble. That's a good thing. Well, the chemistry of open cell foam says, I don't want to hold this bubble. I want to break the window. I want to break it open. And they actually put cell modifiers in there to break those cells so that each cell is connected. It's called open cell foam. So they purposely break those windows to allow air in, to allow CO2 out. Mother Nature likes things in balance. So a lot of CO2 actually puffs the foam up. It's shortly replaced, because it's open, with air. And air becomes, your non-convective medium. So that's really the chemical background.
Okay.
Paragraph 1 of the chemical background, but that's kind of what we're trying to do. In open cell, we break those individual cells open. And in closed cell, we want to hold them because we want to trap the gas.
And so it sounds like it's the same materials. It's just how they end up getting mixed together that determines whether it's open cell or closed cell. Is that fair?
Well, contractors want to mix these materials exactly the same way. Maybe a little adjustments between the temperatures, this kind of thing, maybe a little tweak of the pressure and this that sort of thing, because urethane foam is a 2-component system. There's an A side, it's a drum of one chemical. And there's a B side, and that's a drum of about 15 different components that go into a typical resin. And that's what the systems house, the chemical manufacturers, that's what they do. The object of the game is to get the contractor set up so that he can't see a difference between open cell and closed cell from a processing standpoint, from a reaction, from a handling, from a look and feel, from an installation. They both are installed pretty much the same way. It's the chemistry at the chemical manufacturers that creates open cell or closed cell. Okay, does that address?
It does. And so I was at this seminar recently, and the speaker was telling us that a lot of the time when homeowners are hiring companies to install closed cell foam, they end up installing it wrong. They don't get their mixtures right, and it ends up really being open cell foam. What do you think about that statement? Is that possible?
Well, you can't take a drum of closed cell resin, mix it through your equipment, spray it out on the wall, and quite frankly, bugger it up so bad that it looks like open cell.
Okay. All right.
It just looks terrible. It's poorly mixed. It's cellular. It's not foam.
Okay.
You have to have a drum of open cell resin in order to make open cell foam.
Okay. All right. Got it. That's helpful.
Maybe what he's talking about is something that you touched on earlier, Tom, is that if you don't have proper application, then you may not, achieve the manufacturer's R value. That's possible, the potential. So maybe if it's not mixed properly, maybe that's what, the speaker Ruben's talking about is, touching on, is that you just won't have the R. It could be half the R value potentially if you're not mixing it right.
If it looks like and feels like closed cell foam, 99.9% of the time it's closed cell foam meeting the physical properties.
Okay.
If you, as a homeowner, look at the foam that was installed in the day, because you shouldn't be there while they're installing it, if you see it and you've got questions and you can put your finger through it and it looks terrible, it needs to be removed. It's some undefined mass of goo. It's not open cell foam. It's not closed cell foam. It's not right.
So before we move on, because I want to dive into that more about how many spray foam jobs do you think fail? How you actually clean it up, remove it. I want to talk more about that. But before we do that, I just want to circle back and kind of recap quickly. because we're already at 40 some minutes. We need to wrap this up. But going back to what you're talking about with the application errors, Tom, the things that you would typically see that would indicate a problem. And you mentioned, okay, well, we could have problems with the spray foam not behaving the way it should chemically and not having the R value that it should have. You talked about it shrinking and pulling away from framing members and leaving gaps. You talked about, just visually being able to identify improper foam mixing. But are there any other indications or problems that, an inspector or a homeowner could look at to see that this foam is a problem?
Well, in general terms, and that's a good question, Tessa. In general terms, it's where it's installed. Where was that contractor told to install the product? From a building science, from a code effectiveness, that sort of thing, that's where you start as an inspector. And I feel sorry for these inspectors because they are not trained. And it's unfortunate, shame on our industry, really. We need to get out there. And I get out there quite frequently and do presentations to building code officials. I'm always open to talking to building code inspectors that have questions. I'll be launching a podcast series here shortly on my website that deals specifically with code officials. It's unfortunate that the code official has to inspect something that he hasn't been fully educated on. Yeah, exactly. I feel for them. But so from a building science and a code compliancy standpoint, it's where did you spray the foam? Where in the building? How thick? Now, you can measure the thickness with a little pin probe on the installed thickness. Now, contractors should be doing this every stud cavity.
Really?
Oh, yes, absolutely. Now, they'll tell you that I can look at it and eyeball it.
Yeah.
I live by a certain phrase, and it's in God we trust, all others bring data. So if you don't have a daily work report that says I checked it 15 times and I have an average of 2.3 installed inches, I'm not trusting you. I'm measuring it.
That's a great tip. And I just want to highlight that because there's so many houses I've been in that have, had a hot roof or retrofit foam added, and you can just see the unevenness in the depth of the foam. And if you take a tiny probe, that's an easy thing to do, is to measure the depth. And if you're finding great variances, across a surface area, you're saying that's a big red flag.
Yeah. Now, I'm kind of a nemesis of contractors, but I always when I write specifications for new construction, I always say, if I need 2 inches, say R14 or R15, it's 2 inches plus a half an inch minus nothing. I can't go on that project and find anywhere where you installed foam that's less than 2 inches thick.
Yeah.
Don't give me this nominal thing. It's not nominal.
It's not average. Okay.
You need to be a good enough sprayer that if you can't install something smoothly, it's going to cost you, not me. So my specifications will say 2 inches minus nothing plus a half an inch. And I'll be able to go around that project, even in attics with open cell. I mean, they're quite rough. I don't want to find an area where I'm less than the required code thickness or the specified thickness ever, period. End of conversation.
All right.
Good tips.
I have so much more to ask about. I feel like we're just scratching the surface, but Tom, we got to have you back for a part 2.
Sure.
We cannot, we can't make this a 2-hour podcast, but we could split this up. Are you available for us to record a part 2 with you?
Absolutely.
All right. We'll get another time on the books here, but for today, for anybody listening, this is gold. Anybody listening to this ought to be getting continuing education credits for this. I know I feel like I deserve it. This is fantastic information. Thank you so much for coming on the show, Tom. And
it's a pleasure.
We'll have you on again next week. But if people wanted to reach out to you or find your website or follow you, if they want to follow your podcast when you get started with this, where can people find you, Tom?
Yeah, I'll let people know my website is letstalkpur.com. So that's let's, L-E-T-S, talk, T-A-L-K, P-U-R, short form for polyurethane.com.
Okay.
And there's lectures on there under the continuing education. I'll be posting this podcast on there under articles and conversations. All my other podcasts are there. All kinds of stuff on that website. And as a matter of fact, there's direct links in the continuing education campus to all of the manufacturers and their available training webinars and seminars. So the information and access to training is available.
Great resource.
We got you right here in Minnesota. Not only that, you're in Maple Grove, aren't you?
Yes, absolutely. About 10 o'clock to the city. Yeah.
Wow, I love it. This is great. All right, well, Tessa, what a gem you have found. Tom, I can't wait to see you on the show next week. To all our listeners, thank you for tuning in, and we'll catch you next time. Take care.